Good day friends, today I am going to discuss the capacitance. This is the second part of in previous lecture we have seen the electric field, electric potential related theory and questions. Today we are going to discuss the capacitance and capacitor. It is the most important part. Generally minimum one questions can be asked from here, and from previous part one questions can be asked. Okay. So let's see. We are going to start the capacitance. Okay. Yes, we are going to discuss right now. Electrical capacitance. Electric capacitance. First, we are going to define. Write down. It is the capacity of a conductor to store the charge. Okay. Means this is the capacity of conductor to store the charge. Okay. It is a scalar quantity. It is a scalar quantity. Next, its SI unit is farad. Yes. So once again you see what is there. It is the capacity of a conductor to store the charge. And which type of quantity this is? It is a scalar quantity, and its SI unit is farad. Okay, got it? Please note down. Okay. CGS unit is stat farad. Okay. What is the relation? 1 farad equal to 9 into 10 to the power 11 stat farad. Okay, this is the relations. So you should keep inside the mind. This is the important information you should know. Yes. Write down. One more important point we are writing. Okay. Please write. If we apply potential difference through the conductor B, then flowing charge across it will be Q proportional to B. So flowing charge is directly proportional to the applied voltage. You can write Q equal to CV. Got it? Okay. And this C is the constant and it is called capacitance. Okay, please write down. Once again you see, if we apply potential difference through the conductor V, then flowing charge across it will be Q directly proportional to V, and this is the sign of proportionality. If you replace the sign of proportionality with the equality sign, so you need a constant. This constant is C, and this is called capacitance of a conductor. Okay, write down, please note down. लिखिए where C is a constant, C हमारा क्या है, constant है, and this C is called capacitance of the conductor. Okay, so got it, please note down. Yes, please keep inside the mind one more important point: the value of capacitance does not depend on charge Q and potential difference V. Okay, so you have to remember it. The value of capacitance does not depend on charge Q and potential difference V. तो किस पर डिपेंड करता है, पहले ये याद रखना है. Sometimes MCQs can be asked, so you should know it does not depend on the charge and potential difference. Apart from that, you should keep in the mind, okay, write down the value of capacitance depends first है the size of the conductor, and the medium and the medium. So these 2 points, medium inside the conductor or inserted inside the conductor. So this is very important point. Means what is the capacitance? Capacitance is the capacity to store charge or to store the charge of the conductor. And what is the formula? Capacitance Q equal to CV or C equal to Q upon V you can apply. And what is the unit of capacitance? Unit is farad. And what is the CGS unit? It is the stat farad. And the value of capacitance does not depend on the charge and the potential difference. Okay, the capacitance depends on the size of the capacitor. Size of the capacitor or conductor, or the medium inserted inside the conductor. Okay, so please got it. Let's see the next. Okay, thank you. Okay, now let's see capacitance of a spherical conductor. What we have to study? Capacitance of a spherical conductor. Suppose we have a spherical conductor. Okay, this is a spherical conductor. This is the center O, and it has radius R, and there is a dielectric medium of dielectric constant K is inserted inside the spherical conductor. Okay, let there be a spherical conductor of radius R and a medium of dielectric constant K the electric constant K is placed inside it. Got it? अभी हमने क्या किया, हमारे पास कोई, this is the spherical conductor we have, okay, we have a spherical conductor and it has radius R and this is O is a center and we have inserted a medium of dielectric constant K inside the, okay, so we have to calculate what is the capacitance of this spherical conductor. Okay, got it? Please note down. So we have to calculate the capacitance C of this conductor. So C equal to what happened? Formula C equal to Q upon V. Yes. And this is the Q upon what is the potential of spherical conductor. You know already formula 1 upon 4 pi epsilon naught Q upon R. And if you put the radius, so put here capital R, Q and Q cancel. And if there is a K, so put K is also there. Got it? So what will be the capacitance? 4 pi epsilon naught K into R. Okay, so got it? This is the important formula. Capacitance of a spherical conductor C is equal to 4 pi epsilon naught Kr. Okay, so this is the important formula you have to remember. Okay, now let's see, this capacitance C is directly proportional to the dielectric constant of the medium K and it is directly proportional to the radius R. Okay, so please note down. Please note down. So what we can write? We can write this capacitance C is directly proportional to the dielectric constant K. This is important. And this capacitance of the spherical conductor is directly proportional to the radius of the conductor. Okay, got it? Please note down. Okay, next we want to study, next topic is energy. Energy stored inside a conductor. Okay, energy stored inside a conductor. Okay, कि किसी कंडक्टर के अंदर एनर्जी कितना स्टोर होगा. So write down work done to store charge inside the conductor. Inside the conductor is stored in the form of potential energy. Potential energy. Okay, work done to store charge inside the conductor is stored in the form of potential energy in the conductor. Okay, so electric potential energy it is represented by U and it is the work done. And you can write this is the QdV. Okay, so you have to remember this concept. Okay, got it? Please note down. We will write further. Yes. इसके आगे हम बट लिखते हैं. हमने क्या कहा कि जो पोटेंशियल एनर्जी, इलेक्ट्रिक पोटेंशियल एनर्जी क्या होगा? It is the work done and it is the Q delta dV. And Q equal to CV, you know Q equal to CV dV because since Q is CV. अभी आपने क्या देखा? What you have seen previously, Q equal to CV. So in place of Q, we have inserted here CV. C is constant. So this C will be outside the integral So V dV, and integration of V dV is V square upon 2 to half CV square. Okay, got it? Hence Q equal to half CV square. Yes, please note down. So, note down. What is the formula? This is the energy stored inside the conductor, half CV square. CV square. Okay, since you know Q equal to CV. Okay, so V equal to Q upon C. Put the value here in place of Q square upon. So it would be half C Q square upon C square. So it would be Q square upon twice C. So you have to remember what is Q square upon twice C. This is another formula. So please note down. Okay, got it? And half QD. So you have to remember all these three. Yes. So this is the energy stored inside the conductor. Potential energy, electrical potential energy equal to Q square upon pi C, Q square equal to half CV square, and potential energy equal to half QB. These three are very important. So please remember this, all the three. This is the potential energy stored inside the conductor. Okay, got it? Okay, write down. Okay, some more important point just keep inside the mind. Exactly, the only 50% of the energy of the battery is stored inside the conductor, and the remaining 50% is lost in the form of heat. Okay, so you can remember only 50% of energy of the battery is stored means half CV square inside the conductor, and the remaining 50% energy is lost in the form of heat. Okay, got it? And here energy half CV square we are discussing. This is the energy of the isolated conductor, but electrical potential energy between the two charges is 1 upon 4 pi epsilon naught Q1 Q2 upon R. Okay, you have no confusion because this is the energy and previously we have studied the energy. So what is the difference? Because this energy is the energy of the isolated or individual conductors, and previous formula K Q1 Q2 upon R is the energy of the two charges. So this is the basic difference. So please got it. Yes. Okay, let's see some questions. Find electric capacitance of earth theoretically and practically. Okay, if radius of earth is 6400 kilometer. Take the radius of Earth is okay. What we have to find out? Electric capacitance of Earth. So the shape of Earth is spherical. So we have to apply first theoretical understanding. Okay, theoretically. Just we have got the formula for a spherical conductor capacitance C equal to 4 pi epsilon naught K R. So it is K will be 1. So it would be 4 pi epsilon naught R. For air K would be 1. So what would be the value of 4 pi epsilon naught? Directly you can put like this 4 and pi, value of pi and value of epsilon naught you know, or otherwise directly one way to calculate 4 and 3.14 and 8.85 into 10 to the power minus 12 and r radius. So you can get the radius from here 6400 kilometer change into meters multiplied by 1000. So it would be converted into meters and calculate. Okay, if you got the calculation, or another second way, 4 pi epsilon naught K into R. Okay, directly you can put 1 upon 9 into 10 to the power 9. Okay, K is 1 and R is 64 into 10 to the power 5. Okay, when you calculate this value, then answer would be 711 microfarad. Okay, you can check it. Okay, so this is the theoretical. By theoretical understanding, this is the capacitance of the Earth. But what will be the practical value? First, note down this. Take the screenshot. And after that, we are discussing what is the practical value of capacitance of the Earth. Okay. Okay, what is the practical? Practically what happens? क्या होता है? तो आपने देखा है Q इक्वल टू क्या है? CV, C इक्वल टू Q अपॉन V. In practical purpose, what is the potential of the Earth? Earth potential we take 0, so Q upon 0, then infinite. So in practical purpose, capacity of the Earth is infinite. Whatever the amount of charge you want to give, it will receive, and whatever the charge, so capacity to store the charge is infinite. Practical, this is the practical understanding. But by the theoretical, it is 711 microfarad. Got it? Yes. One more questions we will see. Write down. Okay, see the next questions. One more question we will take. If a spherical conductor of radius 10 centimeter is connected by a supply voltage of 100 volt, okay, then energy is stored inside it. Okay, got it? Once see what is the questions? What is a spherical conductor of radius 10 centimeters? Solutions. एक बार मैं समझाता आपको क्या है इसमें. Spherical conductor we have and radius is given 10 centimeter. R is 10 centimeter. Change into 10 upon 100. It will be the meters. 0.1 meter. It would be the radius. And voltage V is 100 volt. It is given. Yes. You know energy half CV square half. This is the formula of energy. Okay. C is the capacitance. This is the spherical conductor, so apply 4 pi epsilon naught R into V square. Got it? is clear. Half 4 pi epsilon naught is 1 upon 9 into 10 to the power 9. The radius r is 0.1 and b square means square of 100. Okay, now calculate it. Check करो. इसको कैलकुलेट करेंगे तो ये 0.05 microjoule ये आंसर आएगा. You can check this. Okay, today I have seen the about the capacitance. What is the capacitance? What is the definitions? Q equal to CV. The factors on which it depends, the factors on which it does not depend. इसके बारे में हमने बात करी है. उसके बाद spherical conductors, capacitance of spherical conductors, okay, and some numericals and energy stored inside the conductors. These three things covered today. In next lecture tomorrow, we'll go further about the energy density and capacitors. We will see in the next lectures. Okay, thank you very much for getting the class. Thank you.